So far we've looked at scenarios where we compounded monthly, we compounded weekly, we compounded daily. And I just want you to think for a second, what do you think would happen if you kept increasing the number of times your money was compounded? How do you think that will affect your investment? And so there is this concept of compounding continuously, which basically means you're going to compound infinitely. So we want to look at what effect does that have on your investment, and is there really a scenario where your money will just completely grow without bound and never stop growing? And so to oversimplify this problem, we're going to invest $1 at an interest rate of 100%. Now remember, 100% as a decimal is just 1. And we're going to invest that for 1 year. And so what happens is, so my principal is 1, my t is equal to 1, my r is equal to 1. So if we were using the compound interest formula, a equals p times 1 plus r over n to the nt, when we put in a 1 for p, and we put in a 1 for r, and we put in a 1 for t, that simplifies to this formula right here. So what we want to do is use our calculator and see what happens if we compound. So we're going to start changing just the value of n. What if we compound annually, semi-annually, and we keep increasing the number of times we compound? So in order to do this, we're going to use our calculator. I'm going to open up the calculator. And I want to check a few things with you. The first thing is I'm going to have you go to second window, and we're going to basically be telling the computer how many times we want to compound, but we don't want to have to keep typing the equation in, so we're going to use a table. And so your window should look like this. Ignore table start. Where it says independent, you want to have ask highlighted. So this is like a toggle switch. So if I hit enter, it's going to highlight auto. If I go over and hit enter above ask, it's going to highlight ask. And so this is what you want. You want to have your independent variable, you want the calculator to ask you, and your dependent variable should be auto. Okay. The other thing we want to do is I wanted you to check your mode. Since this is the first time in this class that we have used a table, so you should be at normal, your decimals should be at float, radian or degree doesn't really matter, you should be on function, and I wasn't, so I'm going to hit enter, connected, we're going to come down and hit sequential. So for what we're doing, these should all be highlighted to the left, right? And we can just quit out of there. Right, again, so you just use we are in the mode, and you should be highlighted all the way down the left. I'm going to quit out of here. Right. The next thing we want to do is we want to put our expression in y equals. Right? And this is where you would graph. So if you have anything in your y equals, you should clear it out. So I'm going to click clear. You can use the arrow keys to go up and down. If you have any expressions in there at all, you're going to clear them out. Also, if any of the plots are on up here, if any of those are highlighted, see if I hit enter, I turn that on. To turn it off, you just highlight it and hit enter again. So this should be completely empty of any plots or equations. And we're going to type in the 1 plus 1 over, instead of using n, we're going to use x, so we're clicking the x button next to the alpha key, close that, raise to the x. Right, here's our expression 1 plus 1 over n raised to the n, only we're using the x variable, and you're going to quit out of here. So we're going to hit second quit. So we're all set up to start telling the calculator the number of times we want to compound. So we're going to go to, now that we've set up the table, right, we set up the table by using second window, but we're going to go right into the table, which is second graph. Okay. If you have any values in there, you can delete them out. Delete, delete. Okay. So our x value is really the n, and the y value is the value of that expression, 1 plus 1 over n raised to the n. And so what happens to my money if I compound it annually or just once per year? For a year. All right. So if you have $1 at the beginning of a year and you just compound it once at 100% interest, at the end of the year you're going to have $2, which makes sense. You made 100% of your money, which is really like doubling your money. Now, if I compound that twice, I'm going to have $2.25. Compounding it quarterly, type in 4, I'm going to have around $2.44. 12, I'm going to have 2.613. So as you're doing this on your paper, you should be filling in, it's hard for me to do it under the calculator here on the computer. I'm going to type my values in later, but you should be writing these values down in the column right here. Okay. So we're going to do weekly, which is 52. And so again, think about how your money's growing. I compounded it once, I had $2, now I'm up to 52 times and I have $2.69. We're going to do it daily. I'm at 2.71. I'm going to do it hourly. I'm at 2.7181. And now this form of the calculator can only handle so many values, so I'm going to continue on. I'm going to delete the values I've already used up here. You should have written those down. And I'm going to leave off, come down here, and we're going to compound each minute, which is 518,400 times. And you would think if you're compounding that many times, your money must be exploding. But let's hit that enter button. Not a whole lot of change from compounding hourly to each minute. And let's do one more. We'll compound each second, which is 31,104. Excuse me, 31,104,000. And so at this point, I want to ask you, do you recognize that number? Is that a number that you recognize? Because certainly it seems here that no matter how much I increase, that the changes, the incremental changes are really getting very, very small. Another feature of the calculator is that if you arrow over the number, now the columns here are so narrow that it doesn't show all the decimal places, it's only showing 4. But notice when you highlight a number and you look down here, it shows even more and more of the decimals. So this is 2.7182812. If I go up, this is 2.7182791. Okay. But we are definitely approaching a particular value. So I just want you to pause the video for a second and think of a number that could possibly be. Okay, I'm going to just slide this calculator out of the way for a second. And I'm going to type the values in. You should have all these written in. So these are all the values for the what the amount would be after increasing the number of times you compound it up until 31 million. And so the question was, do you recognize this number? Some of you may have seen it before, some of you may have not, but let's pull that calculator back again. We'll quit out of here and get back to the home screen. And I'm going to hit, and some of you may have recognized it, that this number is the number E. So I'm going to hit second and then right above the division sign, which is E, and hit enter. 2.71828 and this is 2.718282. So what happens here is that even though you are compounding continuously, your money is only going to grow to a certain amount. And so that is what we call, it's a limit. There's a limiting factor here. And for this particular problem, the limit is the number E. And so this brings us to a new formula for compounding continuously, which we'll look at in the next video.